Mackenzie, I'm taking a look at the questions you've asked me about on your exam with regards to your confidence intervals and that you're getting the wrong interval. And this is question number 2, where you were basically given a sample of 13. You got a sample average of 3.54 and a sample standard deviation of 0.35. And you're asked to construct a confidence interval. Well, the first thing I noticed that you did wrong is that you're using the normal distribution. I realize you were told that you can assume that the interest rates are normally distributed, but because you do not know the standard deviation of the population, but rather only the standard deviation of your sample, then you're not in a normal distribution, you're rather in a T distribution. Now, a T distribution is also very symmetric. It's just a bit sloppier than the normal curve because you're using S to estimate sigma. So when I look at your work for question number 2, I notice that you are finding your critical value for your margin of error using the normal curve instead of the T distribution. So you're correct in identifying first that with 99% confidence, you've got to take half of what's not in the interval. Well, in this case, the 99% confidence level. So you took the 99% confidence level, 0.99 when expressed as a decimal, you subtracted it from 1, and then you cut that in half. And the reason you're doing that is because in a confidence interval like this, you're capturing the middle 99%, which means you're leaving out 1%, half of which has to be in the upper tail, and half of which has to be in the lower tail. So that half in this case would be our 0.005. So then you're using that information to help you determine the critical value for your confidence interval. But again, the problem is you're using the normal curve. So you're going to your normal distributions table to help you determine what that critical value is, and you should instead go to your T distributions table. So if you look at your T distribution table, what you've got to recognize is that because your sample size is 13, your degrees of freedom is always 1 less than your sample size with confidence intervals for a population mean. So in our case here, 1 less than our sample size would be 12. So you go to your table and you look up a degree of freedom of 12, and then I can't remember if the confidence percentage levels are down at the bottom of that table or at the top, but you go to the column that has 99% identified as the level of confidence, and you see that your critical value is 3.05. In a normal curve, you'd only have to go out 2.58 standard deviations to capture the middle 99%. But because the T distribution is a little bit sloppier, which means it's not as tall in the middle and it's thicker in its tails, you have to go out a greater number of standard deviations to capture the middle 99%. So you then in turn will take your basic formula for your confidence interval for a mean is to take your sample average x bar plus or minus your critical value t star multiplied by your standard error, which is found by taking s over root n. So you did everything about this correctly except for your t star. Your t star should be 3.05 rather than 2.98. So that's what your confidence interval would look like. So then when you take 3.54 minus 3.05 times 0.35 over the square root of 13, you get a lower boundary of your interval equal to 3.24. When you take 3.54 plus your critical value times your standard error, you get an upper boundary of about 3.84. Now, I haven't looked further at your other confidence intervals, but I'm guessing you may have made the same mistake in using the normal curve to find that critical value instead of the t-distribution. But I'll take a peek at it and let you know if I notice any other mistakes. Don't hesitate to email me if you've got some questions.